Hi, Kipsters. This is the test corrections for test number 1 called a reintroduction to fractions. We're not going over every problem, but if you could take your worksheet out now and you'll see which numbers we are going to go over. These are the ones that most or many students got some points taken off for. So here we go. Please check out number 11. The question says, are 3/5 and 12/15 equivalent fractions? Prove it and explain your reasoning below. So obviously, in order to understand what this question is asking, we need to understand the key phrase, equivalent fractions, and what that means. And I wanted to draw your attention to this, which we've seen before over the summer. Are these two fractions equivalent, 3/5 and 12/15? The answer is yes, they are, because they are multiplied by a whole. And one whole, in this case, comes in the form 4 over 4, which is equal to one whole. So two fractions are equivalent if you can multiply them by one whole. So you'll see one Kipster's response to this actually uses that explanation. So let's check it out. I know it's a little messy, but up here it says 3/5 times 4 over 3 equals 12/15. Now that is true, but watch what this Kipster wrote. Are 3/5 and 12/15 equivalent fractions? No, because you have to multiply by a whole. But in this problem, you have to multiply 3 over 5 by 4 over 3, which is not a whole. So in this case, the Kipster used the strategy, check to see if you can multiply the fraction by a whole to get to the other fraction. In this case, you could not. And that's why this Kipster proved that they weren't equivalent. Let's check out another way. Okay, this might be a little tricky to see, but check out what this Kipster did. I want you to take a look at it for a second. Okay, they have 3/5 and 12/15. I see 12/15 here, and they multiplied it by 2 over 2 and got 24 over 30. And they got 3/5 over here, they multiplied it by 6 over 6, that's 18 over 30. It looks like they tried to make these fractions speak the same language or have a common denominator of 30, which I know a couple of you did, and it's a really smart idea. Listen to this response. 3/5 and 12/15 are not equivalent fractions because 3/5 times a whole is 18 over 30, and 12/15 times a whole is 24 over 30. Therefore, they are not equivalent. If they came out, if you tried to make them speak the same language and the numerators were the same, then those fractions would be equivalent. So another strategy you could use is create fractions with a common denominator, make them speak the same language. Then check, like this Kipster did, to see if the numerators are the same. They are not, therefore these are not equivalent fractions. One final way, kicking it old school, which some of you did, and because the question didn't say that you had to use a specific strategy, you could have gone old school with fraction families. You could see this Kipster did the 3/5 fraction family, 6/10, 9/15, 12 over 20, 15 over 25, and they circled 12 over 20 because if it was 12 over 15, it would be equivalent, but since it's 12 over 20, it is not. Let's see what they wrote. 3/5 and 12/15 are not equivalent fractions because, as you can see above, I showed work on how you can prove that. I made fraction families all the way to 12, and I got 12 over 20, and 12 over 20 is not equal to 12 over 15. So 3/5 and 12/15 are not equivalent fractions. So a third way you could have tackled this problem was kicking it old school and creating fraction families. So to sum up, 3 ways. If you have fractions and you want to check if they're equivalent, here are 3 strategies you can use. Check to see if you can multiply the fraction by a whole to get to the other fraction. Create fractions with a common denominator, also known as making them speak the same language. Or you can create fraction families. Hopefully that helped you understand and make better sense of number 11. What I want you to do now is you'll see your YouTube screen. It'll look something like that. Can you please click on the pause button and now complete the rest of this section for number 11. Don't go on to the next ones, just press pause now and then click play again afterwards, and we'll move on to the next one. So click pause. Okay, back to number 15, the next most commonly gotten wrong question on the test. It says, without, I repeat, without doing the actual addition, how can you tell which side is going to be larger? Once again, you will not get any credit for doing the addition. 1/2 plus 1/4, and then you're supposed to either draw a greater than sign or a less than sign versus 1/3 plus 1/5. Take one wild guess what the most common blunder was on this question. Yep, you guessed it. People added, and it said not to add. So, most common mistake, people didn't follow directions. They got 3 points off for that. Now, without doing the addition, what could you do? So what I did was I went into the classroom and I actually found these great fraction pieces. This is 1 whole, then all of these are equivalent to 1 whole, but you can see something, and it's something we've talked about quite a bit over the summer. You see that 1/2 and these half pieces are larger than 1/3, are larger than 1/4, are larger than 1/5. So what I wanted to show you was I actually split up the pieces to 1/2 plus 1/4, 1/3 plus 1/5. And if you stack them on top of each other, which side do you think is going to be larger? Well, look, it makes sense. 1/2 is bigger than 1/3, and 1/4 is a little bit bigger than 1/5. And yes, I know I showed Miss Emery and Miss Abramson because it's that big of a difference. Look at 1/2 and 1/4, the two bigger fractions. Look at 1/3 and 1/5. It's like comparing Miss Emery's height to Miss Abramson's. It's no contest. 1/2 plus 1/4 is larger, and you didn't need to add to prove it. You just needed to recognize something about the size of the pieces that this next example explains perfectly. It says, I think 1/2 plus 1/4 would be larger because all the fractions have the same numerator. And if fractions have the same numerator, the one with the smaller denominator is larger. That is so super important. The larger the denominator, the smaller the piece. You all learned that with Miss Vasilla last year, and if you didn't have Miss Vasilla, you probably knew it anyway. Everyone says it. The larger the denominator, the smaller the piece. But you must remember, like this Kipster did, that that's only true when the numerators are the same. I'll say it one more time. The larger the denominator, the smaller the piece. But you must remember that that's only true when the numerators are the same. In this case, the numerators are all 1. Therefore, as this Kipster wrote, the one with the smaller denominator is larger. 1/2 and 1/4 have a smaller denominator than 1/3 and 1/5, so 1/2 and 1/4 would be larger. Okay? That's question number 15. Click the pause button now and finish up the couple of questions I asked for that section on number 15. Go ahead and click pause. Moving on, 2 more left. Number 16. It says, using words, numbers, pictures, symbols, or number lines, explain which of the following is closer to 1 whole, 5/4 or 4/5. Man, this problem was a pain in the butt for many of y'all. And what some of y'all did was you went to number lines, and I appreciated that. Some people, first they wanted to make 4/5 because they thought that, I don't know why they made 4/5 first, but they did. And they found 4/5 to be right over here. And they said, oh, look, that's like kind of close to 1 whole. Look, it's not that far away. Let me check 5/4. So then you made another number line, and you made 5/4. You cut into 4 equal pieces. 1/4, 2/4, 3/4. That's 1 whole, the same as 4/4. And then you found 5/4, which is coming up next. You said, oh, 5/4 is also close to 1 whole. And the problem is that some of you said, oh, 5/4 is past 1 whole, therefore it's further away. That's not true. Just because it's past the whole doesn't mean that it's further away. But the problem is that in this picture, it almost looks like they're equally away from 1 whole. And that's also not true. And the reason why is because, as you remember over the summer, when we're comparing, we want to line up the holes, and these whole numbers are not lined up. I'm going to show you an example that a Kipster showed. I think it was Eric Valerio, who on his test showed, and as I said, you can't do that because it's not lined up. But Eric, this is his paper, and I want to show you what he did, because the most important part is that he lined up the holes, and then he made perfectly equal size fifths, and he actually went on to 8/5, and then he made perfectly equal sized fourths. And only if you drew your number line like this, where the hole was lined up and your fourths and fifths were perfectly equal, was I going to give you full credit, because then you can see that 4/5 is a little bit closer. Look at that jump versus this jump. 4/5 is a little bit closer, and some of you put that, but I didn't give you full credit because your picture didn't explain it well enough. But there are a couple other ways, because drawing these number lines as perfect as Eric did is really hard. So I want to show you another explanation that one person wrote. They wrote 4/5 is closer because fifths are smaller and fourths are bigger. Let's reread that again and think. Fifths, that's right, they are smaller and fourths are bigger. The bigger the denominator, the smaller the pieces. So let's think about this for a second. Think about 4/5. Look down here. 4/5 going to one hole. How much do you need to get from 4/5 to one hole? How much more do you need? That's right. You only need 1/5 more. Now, what about going from 5/4 to one hole? How far away is that? What do you need to take away to get to one hole? That's right, 1/4. Now take a look. 4/5 is 1/5 away. 5/4 is 1/4 away. As this Kipster wrote, fifths are smaller than fourths, therefore 4/5 is closer. Again, not an easy thing to explain, but if you just think about it for a second and think about how far away they are from a hole, it's going to make sense. One more way. Now check this out. This Kipster didn't do any of that stuff. They just made the fractions speak the same language. They made 5/4 and 4/5 both speak 20ths, and they did that by multiplying by a whole, in this case 5/5, and down here 4/4. They got 5/4 is 25/20, and 4/5 is 16/20, and they noticed that if you took away 5, you would get to a hole, but in this case, this was only 4 away, so 4/5 was closer. Isn't that interesting? They made equivalent fractions, and then they figured out how far away it was. This was only 4 away. That one was 5 away. Therefore, 16/20, which is the same as 4/5, is closer. Okay, take a second to copy one of those ideas down, and just think about how these all make good mathematical sense. Click pause one more time, and then copy that stuff down, and we'll be back in a second with the last problem. And the last problem. Sorry for that extra arrow there. And it should actually say number 17, not number 16. But of course, I got all messed up because the problem's about me and my wife. Mr. Browski and Mr. Negron have 2 identical coffee mugs. If they combine the coffee in both of their mugs, it will not overflow. In fact, it doesn't even reach the top. Mr. Browski's mug is 3/4 of the way full of coffee. What fraction of the way full of coffee could Mr. Negron's mug be? Show your work. Okay, so here's the deal. I have a feeling a lot of people just didn't read this problem carefully enough. One mistake, not the most common one, but one mistake was that some people thought they circled 2 identical coffee mugs. And then they thought if Mr. Browski's mug was 3/4 of the way full of coffee, so was mine. But I didn't say that. I just said we had the same mugs, not that we had the same amount of coffee. So that was one mistake. But those people who even understood the problem, here's what some people did. Oh, by the way, if you didn't know who that is, that's my wife, and that's me. I know I'm good looking. Okay, here we go. They drew a mug, and here's Mr. Browski's mug. Mr. Browski's mug is 3/4 of the way full of coffee. That's my mug. Let's talk about Mr. Browski's first. 3/4 of the way full. Okay, and you can look. If this is up here, it'd be 1/4, 2/4, 3/4, and if it went all the way to the top, that'd be one whole. Mr. Browski's mug is 3/4 of the way full of coffee. Okay, so the most common wrong answer, because how much coffee could be in my mug? You know what people put? They put 1/4. And of course they did, because if you look at it, if you take this amount of coffee and pour it in here, it perfectly reaches the top. So people's most common wrong answer was 1/4. But if you look back at the problem, it says, look over here. In fact, it doesn't even reach the top. Therefore, 1/4 is wrong because 1/4 would perfectly reach the top. And there needed to be an amount of coffee in my mug that did not reach the top. So you needed something that was less than 1/4. Anything that was less than 1/4 would have been an appropriate answer. Some people put 1/5, 1/6, 1/7, 1/8. All of those fractions are perfectly fine. There were a ton of different answers, but the answer had to be less than 1/4. If you ever get stuck with a problem, and this one was tricky, just reread it, underline the key information, circle the question, okay? And then do like I did and draw it out. Draw the coffee mugs, make sure they're identical, and then just do exactly what the problem says, okay? Last thing, before you go, I know you have an extra problem to do for number 17, but do not forget to get this test signed. So go hand that over to your parents now, and go ahead and finish up with number 17. Thank you all for chilling. I'll see you all tomorrow morning. Call me if you have any questions. 917-455-4770. Deuces.